Alright, so let's continue on. Obviously, we have a lot more to do with controlling the movements of these characters, and I get to finally reveal to you all why we are using an object here. Alright, and remember our NS number is an object. It's because I want to put in a line like this. And by the way, I am just in the handle swipe down method. We're going to do the same thing for all of our handle swipes. Alright, so we're going to write character and then perform selector at selector. That's still going to end up being this same method right here, so you can just paste that on in. Do a colon after it because we're going to pass in a parameter, and you do have to specify that colon if you're going to pass in a parameter using this. And now we're going to put in this right here. Okay, let me move this off to the side temporarily so you don't have to worry about it. And then after delay is going to be, for right now, let's just put in our variable place and then multiply it by 0.25. Okay, and of course we're going to replace that with a property from the the property list in just a moment. But this right here will do exactly what we had before, and let me bring that back. There's really not too much of a change to it, but it's just delaying how quickly the following characters react to that movement. So let's go ahead and take this same line now, and we'll paste it up here. Of course, we want to then put that in there. And would you believe later on we're going to be even doing another if check inside of this else statement to see if this use, or basically, yeah, if the following delay is even going to be a part of the action. But for right now, let's just test things one at a time. And there we go. Doing a lot of copying and pasting. Finally, move left with place. And let's see what happens. Of course, the first time around, or if the leader is found, there's obviously no delay. But then anybody after that is going to have that equation applied to them. And one of the things you'll probably see that's kind of obvious is that the this will work well in some directions where the leader is already the front man visually, but you know, when we go like to the left or something like that, you'll see that he's kind of walking behind his group. All right, so go down, go up like that, and here's what I'm talking about. See, even though he's the front man, he still can't really get out in front of these guys. All right, there's just a little problem there. So I guess I'm back to using squares again. All right, I'll set those to circles in a little bit. So that's certainly something that we're gonna have to account for. But you can see that this is kind of how things are gonna work out, and there is that little bit of a delay. So let's fix it further. All right, so now let's head over to our character class and go over here to the header file. What I'm going to need to do is kind of narrow down who is the leader, obviously, and if they're not the leader, basically create an ideal position for them. All right. Now remember, I don't want these characters to kind of immediately swing into a perfect line. All right. I want to kind of them follow the leader naturally. Okay. So there is that little delay, and then they've got to shift themselves subtly into a line, or a column, whatever it's going to be. So I'm going to set in here a variable called ideal x and ideal y, and then I'm going to also create a Boolean variable so that within each one of these classes it knows whether or not it's the leader. All right, and I'm doing this inside of the header file as opposed to the @interface part of the implementation file, because unlike these variables that are accessed only within this method, I want the variables that I put inside of here to be accessible to other classes. All right, so they can they could, in this case, they could find out both what the variable equals, and also they could set it to. And what am I doing? What am I writing that? I need to put in here property, non-atomic. That just has to do with multi-threading or something or other. I can never remember. And then put in here assign, and this is the important one. So another option could be something like read only, read write. Assign, so that means that our level class could give this a value, and then we're just going to put in here int ideal x, and let's go ahead and copy this same line over here, ideal y. And let's throw in one more. Not sure why that error is showing up there. Bool. And then we'll just make this one be the leader. So if this equals yes, this particular instance of the class is going to be the leader. And then if not, you're obviously just a follower. All right. And while I'm over here, let's go ahead and just put in here a declared method called make leader, and then we'll step over here to let's go to the very bottom of our implementation file and just write in here pragma mark leader stuff. If I remember right, we might even have a demote leader method, but I can't remember if that made it into the final project or not. I do remember thinking I'll probably have a demote leader. All right, so make leader. Now, this is kind of interesting. When, well, let's just write it up. The leader equals yes. Okay, we should see not an error, but a warning, I believe. Or an error. There it is. It says use of undeclared identifier, the leader. Did you mean? And then it says underscore the leader. Well, yeah, that is the correct bit of code there. But why it is... why is that? This is not something that I've gotten 100% used to yet. Coming from the Cocos 2D world, I didn't have to declare my my variables like this, or I didn't have to use this kind of protocol or whatever, where the properties that are declared for other classes to access get this underscore put in front of them when you're within that particular class. Okay, so if we wanted to reference our ideal x in here, we're going to put underscore ideal x. And I did a bit of when I realized I had to do that, I did a bit of researching and stuff like that. And the examples, if I were to kind of explain them in the video here, I think they would make less sense than if you just go out there and you Google something like, why do I have to put the underscore in front of those? Just know that that's how it's done, and otherwise you'll get that simple error message that pops up and tells you otherwise. But oddly enough, when we're outside of this particular class, we just put the leader when we want to access it. So for example, we can go over here in just a moment and test that out. But prior to that, let's come up here and just trying to find setup characters. Okay, so leader, and actually at this point, because there's nothing more in that in this method other than setting that variable, this would really be no different than writing something like leader dot the leader equals yes. Oops. Oh, there we go. So we could do that as well right here. But if I remember right, we do have something more to do inside of that method. But so let's just keep that as is, and then it gives us a little bit of flexibility for later. But you could test that, or I mean, you could set that, and you could also test it too. You could say something like if leader equals yes. So you can perform an if statement now using that. All right, so all this comes down to our update method, because that is where we're going to put in here some sort of we're going to pass in the ideal x and y position of the leader, so that our followers kind of get into that formation. So what we have so far is fine. We're going to work inside of our self.paused equals no statement, and we're going to say if character equals leader, and remember right now we're enumerating through every one of our characters inside of here, so it should find the character first. In this case it's actually alright if it doesn't, but later on we'll make sure that our leader is always the first sibling to be found. And now if well, here, put a little note that says put something in here later. Otherwise what I could do is just put if the character is not equal to the leader, but we are going to put something in there later. I just don't want to get into it right now. Else then we're going to say character.ideal x, and again, see I don't use the underscore there, equals leader.position.x, and then we'll do the same thing here, character.ideal y equals leader.position.x. And if you're kind of curious what's going to come in here later, is we're going to eventually just test to see if any leader has been found in the update method, and if not, then we're going to step outside of this block and we're going to basically assign a new leader if there is a follower. Okay, if there's not a follower at that point, then the game's over. Alright, so we've got this. We're passing in this value, or I'm sorry, we're passing in this value to this instance of the class, and we'll do something with that in the update method. Alright, give yourself a little bit of room to work here because you're probably going to need it. We're going to be putting if statements inside of each of these conditions, and the first one here is going to be if self.position.x is less than the ideal x position, then and you're not the leader equals no, then we're going to speed you up just a little bit on the x-axis, okay, to basically get you toward that ideal x position. Now think about it. Suppose your leader in the chain is going to be going upward, okay, so you're incrementing upward on the y-axis, all right, that's where your speed is getting applied to. And we're seeing if your x position is just kind of too far over here, all right, your ideal x is less than, okay, so that's where the position is. You're over here, but the chain is going up this way, right? So what we want to do is add a little bit to that, and then if your character's over here and you're going up this way, it's just going to kind of slowly move that character up into that line with everybody else. All right, and to do this, we just put in here now self.position equals CG point make self.position.x plus 1. All right, so if you're less than what the ideal is, we're going to add 1 to you, and you're just getting 1 added every frame, right? And then we leave your y position alone. Okay, we're not going to mess with that. And let me just tighten these lines up a little bit because we're going to put another else statement right below that one, and we're just going to write else if, and then just do the opposite. So if you're actually greater than the ideal x, then we're going to subtract 1 from you, and we can do the same exact thing if didn't like what I put there if you're going down too. All right, because both for the up or the down, we don't really care about we're not adjusting the y position at all, we're just dealing with the x. And then let's kind of now reverse everything for the y positioning, for going left to right. So we're going to change that. If self.position.y is less than the ideal y and you're not the leader, then we're going to leave your x-axis alone, but we're going to add 1 to the y, and same thing here. Okay, and I think we got everything. Y. Okay. And before we test, let's go back and set these two circles, because depending on the follow delay, if you just have a square, when the physics are kind of colliding with each other, what can happen is basically the two squares just, or a square hitting another square is just going to push the initial one over a little bit. So that's not really what you want. And ideally for these collision shapes, circle is always going to work best. So let's go and give it a little bit of a test now. All right. Okay, so go down, and you'll see, and they're kind of falling behind there. All right. And one of the things that we're going to address when we have the characters stop is how to kind of put these put them better off into a line, right? Because at least for right now, everything's okay when we're going kind of this direction and this direction, but well, I guess that direction's right too. It's we do have a problem when we're going up, because that's our leader and he's kind of pushing into all those other people. But we're getting there. And by the way, if you see a little bit of an overlap here, it's because I actually realized something about when I created the circle boundary for the or just the green line around this is not actually the true representation of the circular physics body. It's correct on the diameter is right. Okay, see, that's correct, but my ellipse is getting applied inside of a rectangle, whereas the physics body is in a perfect circle. So we should actually go ahead and just fix that real fast. Let's go back over here. Find there it is, the else statement that sets up the create with ellipse in rectangle. I'm just going to paste this line in for you. It's we're just going to make CG rect adjusted rect equals, and then we just keep that the exact same. That's the exact same as it was before. That's the same, but this will be the width. Okay, so basically we're just taking the width and putting it in there for the height as well, so it's a perfect circle. And because right up here, body was circle of radius, so that was not body with ellipse. And now everything, if you were to publish this again, you'll see that those circular shapes do match up with their actual bodies now. So come down here, doink, see how that works. And by the way, because the frame rate is down to 30 frames per second here in the simulator, but on the devices it runs at 60, so these guys actually fall into line or kind of into their ideal positions a lot quicker, right? With what little time we got left in this video, let's go over here and actually I keep saying go over here, but we're in the same class. Let's adjust the rotation of each of these characters, and that adds quite a lot more realism to them kind of moving around as well. One thing we'll do actually prior to that is put in, and you can just paste these in, these two methods for changing degrees to radians or radians back to degrees. And once we do that, once you have that in there, then you can just easily write in something like this. Character dot z rotation is going to equal degrees to radians, and if we're moving left, it should be -90. Okay, and let's go ahead and just put these in real fast for all the other ones. Actually, if you're moving down, I think we're back to 0. So let me check them, make sure I got them all right. All right, so if you're moving right, we're going to go 90. If we are moving up with play, yeah, moving up, that'll be 180. And then, yep, sure enough, this just goes back to 0. But of course, you do need to put that in there because these other ones could have been adjusted, and then you'll want to go back to 0. And these methods all have a lot more to them later on once we're running through different textures and things like that. But for right now, let's give this a test as is before we start encapsulating things in else if statements or else statements, whatever. And all right, so that obviously did not work out that well. Okay, well, that's moving down. Sorry, that's why that's happening. Okay, but the other ones are moving correctly. So we just need to swap out that with the 180. I'm checking my notes later. I'll have to remember that I don't have these two methods written in the same order. All right, so now there we go. So now he's going up, down. You can see how that little change in the or that delay takes place with obviously the rotation too, which kind of looks good. So it's sort of like, hey, wait, we're going left now? No, wait, we're going right? All right, cool. All right, good. Let's come back in another video and we'll start dealing with, well, more of what we got to deal with here.